Hello and welcome to my experiment 3. So for the experiment 3, I will be following the procedures laid out on the blackboard. So let's set let's set everything. Let me open this, minimize. Okay, so uh, let me just fix this for a second. Okay, so for the experiment 3, entitled Programming with Time Delay Using 7-second Display. So uh, these are the learning objectives to apply the experiments 1 and 2. The concept from the past two experiments. Understand, use the set of 8050 microcontroller to, of course, use the 7-segment display with a time delay and demonstrate I/O interfaces work through time delay. Okay. So let's go to our first part 1 for the procedure. So first, launch the EdSim. So this is the EdSim. Click new. Since this is already fresh, I don't need to do that. So let's what do you call this, initialize the addresses again at 0, 0, 100 and copy this following code. So let's do that. Start colon set b p3.3. Let's see if I can copy paste this one. So, oh, I can't. So let me just copy paste. So set b 3.3, set b 3.4, move 1. This is binary. So this is how many? 4. So in hexadecimal, this is F and 9, F9, I believe. Yes, this is F9. So this is 4. So this is A4 in hexadecimal. This is B0 in hexadecimal. This is 999 in hexadecimal. So let's analyze this first. So to start, the set B will be, oh, excuse me, P3.3, and we move, well, so after, so this will be set, move, call delay. So the delay is right here. So it will start with 45 hexadecimal. So it will decrement until R0 is 0, and then we'll return to the previous line where the delay is called. So see, let's save the program and see. Since this is my third experiment, let's call it experiment 3 part 1. And okay, so let's assemble the program. Let's see. Okay, syntax error. Oh, yes. Let's fix the okay. Let's see. Let's save it again since we changed one. Yes, we overwrite it and we assemble. Okay, no errors. And for this program, choose one frequency, click run, and answer question 1. So as you can see, this is the delay. We are we are having a delay. Oh, let's pause. Okay. Let's run. Okay, so we call delay again. Now it became 3 right here. So as you can see, there's a 2 and there's a 3. Also, these values are for the 7 segment display, so it is not actually a hexadecimal, but rather in accordance to the A to G binary combinations for the 7 segment display. So this is A, B, C, D, E, F, G, and that's the values of this. So we are now at 1. So this is 1. So we are now at right here. So after the delay, this is the binary for 2. For the 7 segment display, now we have 3 and this is 4. So let's analyze. Set B 3.3, B 3.4, call B1. Okay, so let's check the questions for this. So I will fix the format later. So what is the output of the program? Illustrate it using a picture or a drawing with an explanation. So the output of the program is a what they call this a 7 segment display of the values 1 to 4, starting from the left and ends to the right. So that as you can see here, so let's keep it running. So as you can see, this is a infinite loop, so it will not stop unless we click pause, because here jump to start. So after calling the delay, we will go back to start, and this is the 7 segment combination for D1. With a delay of each output is shown once per digit of the 4-digit 7 segment display with a delay value of 45 hexadecimal, as you can see right here. Uh, so it follows the decrement jump if not 0. So excuse me. So the dollar sign means excuse me, that it will remain on program counter 24. So that's why, as you can see, there's we are stuck here at line 20, program counter 24. And since we're dealing with the 7 segment display, we use the complement of the actual values that we want to use. So that is for the question 1. So analyze the program and its output. Okay, so let's pause the program, reset, and repeat. So edit the program, remove B from the instructions. So I believe these are all these sets. So let's see, 1, 2, set B, set B, set B, set B, set B. We have 3 set Bs. Wow. Wait, so one, two. Let's see. One, two. Oh, what this step 10 is talking about is the move P1 command. So let's remove this and turn this into 0004, 000B, 0014, 0014, 001B, 001B, and let's run. Okay, so repeat steps 4 and 6. So save it. Let's overwrite and let's assemble. See no error, so let's run. So let's analyze. Okay, so we have one error function set not called. So we have an error. So maybe it is as a question. So the B stands for binary to indicate that the combinations of ones and zeros are in binary form. So are there any effect to the program when B is removed? So let's see. Let's make sure that we are not messing things up. So 0004, 000D, 0014, 001B. So again, let's run set and run it. No errors, so let's run. So as you can see here, set B. Okay, we are now decrementing, but at the start, 3.3. Error function set not called. So let's see. So let's see. Okay, we are now at here. So function set not. Okay, so this is the second one. So since binary 0, so this is all 0. And 4, which is 0, 1, 0. Okay, we reach this one for 14, which is 100, which is 011, 0. Okay, we have here 1, so this is 1, 0, 0, and everything is 0. Okay. It follows the binary 4. So as you can see, the actual binary value of 4, which is uh, actual binary of 0, which is everything 0. And this one, I'm not quite sure. So let's see. So here we have 0 1 1 1 0 0 0 0. Okay, so let me just pause. Okay, so after careful analysis, so I realized that uh, on the third LED right here, this is the binary of 14, which is 1110. So as you can see, if we search it, this is the binary. So it since uh, this one is read as hexadecimal, this one is read as binary. So no, so everything is read in binary. So this is just convenient for us to put 14 instead of the binary combinations of the 14, which is right here. So the B stands for binary, and that indicates that the combination. Uh, the program converts the values as seen in 004, which is seen 004 and 0014, that became 0 1 2 3 4 0 in the leftmost digit of the display, and 0 0 0 1 1 0 in the third to the left third of the display. So so as you can see, even if we don't use the B, it converted the microcontroller converted it into binary. So as seen right here, this one has B, this one does not have B, and we still get the binary combinations for 14. So okay, so that is for question 2. I will fix the formatting later. So, but this time, edit the program by adding numbers 5 to 9 in the loop and to be able to display it through SSD. So, with this, we will revert our program. So, okay, so excuse me. Let's copy paste this. Okay, so let's say okay. So uh, we are asked to add the numbers 5 to 9 in the loop to be able to display through SSD. So since this set B is actually seen on here, so we are setting the ports. So setting the port 3.3 and port 3.4, which is responsible for choosing which ports to be used and to be used. So instead of moving P1, moving values to P1, clearing the P1, and then moving values to P2 and then clearing the P2, we're just using one one variable and it gets multiplexed in 4 different digits. So let's see. So since this 5, 6, 7, 8, 9, we're adding five new digits. So you just copy this, but we will change this one. So I believe there's a 7 segment combinations right here. So let's add a comment. 1, 2, 3, 4, and this will be 5. So 5. So 5 is 1011. Okay, so 1011 011 1011 011 1011 011. Okay, so that's for 5. And let's see, let's copy this. So let's see. So set, so this is 1 1, that's for this one. So if we here 0 1, this is 0 1, this is right here. uh, very sorry. 001112. This is for 6. So let's see, this is 1 1 0 1 0, I believe. Okay, let's try. Okay, no. Let's see. Call delay. Let's move this into this one. And let's try assign that. So let's run it. So we now have a value of 1. Let me check if I'm recording. Okay. So let's just increase the frequency. Okay, that is too fast. So we're now at 3. Okay. Excuse me. So we now have a value of 2. We're now at this 9. We're now at 3. 4 should be 5. Let me just figure this out. Okay, so I figured out the error. I should be coding this backwards in conjunction with this. So A should be on the right when I'm talking about this. So A, B, C, D, F. So that's how we are doing that. So just okay. Excuse me. This should be 6. So let's do the 6. So this is 1100. So should be 1100, 1100, and 1100, 0001. 1, 2, 3, 4. So that is for 6. So this is 1111, 3, 4, 1, 2, 3, 1. At 8, everything is 0. 1, 2, 3, 4, 5, 6, 7, 8. So then for delay, so this is 9. So let's do that. Oh, this is 0, 0, 1, 1, 3.0. So 0, 0. Alright, 1, 1, 3.0. So let's see. Symbol and 6, 7. Okay, so there's an error on the digit 7. So this 25. So let's see. Oh, this one is inverted. That's why. 0, 1, 2, 3. Okay, so let's see. You can see you just repeat the set B. So in order to multiplex the digits that we are going to use. So I think that's it. So let's reset. Let's just copy paste. So This code is added after the delay of digit of number 4. So that is for the question 3. Let me check if I'm recording. I'm recording. So let just okay. So it says answer question 3, 3, 4, 5. What is that? Yes. The, out, the output is a rotating display starting from the left with digit 1, 1 up to digit 9. So I will add the picture later. Why is multiplexing important in utilizing the SSD? So multiplexing is done by using the which is responsible for the display the 4-digit 7-segment display. It chooses between the digit depending on the combination. It is done by using set B or clear with the arguments with P3.3 or P3.4 as their argument. It is important in what do you call this in memory space since the program uses a the register P1 through all throughout the code, which gets displayed depending on the values of P3.3 of the multiplexer 3 and P3.4. So cite an example. So uh, let me just hello, and so I added a few words. So right here, so multiplexing is done using the P3 and P4, which is responsible for this 4-digit 7-7 display. As you can see right here on the right, here P3.4 display select 1 and gate, which is the multiplexer for this 4-digit 7-segment display. And so it chooses between the digit depending on the combination. So if the combination is 1 1, this will be used. If the combination is 1 0, this will be used. If the combination is 0 1, then this will be used. And if the combination is 0 0, then this will be used. And in my code, so I just rotated it. So 1 2 3 4, and then 5 6 7 8, and then 9. And from 9, since 9 is on the leftmost digit of the 4-digit 7-segment display, it will turn to 1 on the same place with after the iterate, since R1 is coded at the leftmost digit of the 4-digit 7-segment display. So it is important in saving memory space. So instead of having 4 variables, or let's say having 9 extra variables to store these combinations. uh, uh, let's not let's see, instead of having 4 variables uh, moving p1 with a value of 1, 7 segment value of 1, then clearing p1, and then moving p2 with this 7 segment value of 2, and then clearing p2, and then moving p3 to connect this. So instead of doing that, we just multiplex them, and as you can see, we are only using three ports, which is P1, the 3.3, and the 3.4, instead of using 4 ports and uh, having the hassle of turning off the previous port. So with this, we are only moving the port P1 across the 4-digit 77 display. And it is very useful in, for example, in communication systems where multiplexer is used to deliver or relay messages from one source to many users. So let's move on. So for our part 2, yes. Uh, okay, so for our part 2, so for the part 2 IO interface delay, okay, so we launched it. So let's just copy paste the code again. So the org is for the to set the address at 0. Again, we are, as you can see here, we are still using the multiplexer right here, and we have a function called 1, and then after 1 call delay, we move we move p2 to a, we move a to p1, call delay, we clear 3.3. Okay, so okay, save your program. Since this is part 2, let's call it part 2. Okay, okay. Let's put the speed to 1. So just follow the instructions and we can let's run it. Okay, assemble and run. Okay, so as you can see here, we are having a delay to start. So I think there's a problem on my let's see, because our program counter is not moving properly, and we are not the second part of the delay. Okay, so let me just reload. So let's save it. Oh, suddenly, okay, let me just reload, and let's load our experiment 3 part 2. Experiment 3 part 2. Let's open it and let's assemble. No error, let's run. So that is for the first delay. So we are not second delay, but nothing is going on. Let's see. so let me check if there's an error. Okay, so I would like to make a correction. So these switch are called port 2 and this one is called port 1. So we use the multiplexer to choose between the the digits of the port 1. So I would like to correct that. So okay, so then with the port 2, which means we are using the switch. So let's try showing the 1. So which is this value. So let's see. Maybe let's reset it and then assemble. So this is for the first part of the P1. So this is again, this is P1, this is P2, and we are only multiplexing using the P3.3 in between. So after testing, I realized that there should be an input from the switches. So I already said that, but the frequency should be lower than 100 because at 100 I cannot see the what they call this, the output. So let's just use one. I know it's very slow, so let's just assemble and run. So we are pressing the 7 segment combination for number 1, and let's see. So we first call the delay. So we set them, so this one should be working. After the delay, P2 is moved, so the value here is moved to value here, right here. So we are now calling the delay. So let's see this one. So let's add a different combination, and let's wait for the counter to trickle down to 0, and let's wait for the function 2 to run itself. So let's see. There. So as you can see, it moved from 1 to 2 with a different 7 segment output. So that is for the what do you call this? The step 7. So let's answer the question. So question 1, 2. So what is the output of the program? So of course I will add the picture later, but I'll just add the explanation. The input is detected or gathered at P2, which is the 8 digit switches, which then gets sent to register A and then gets sent to P1. The digit of the 4-digit 7 segment display is identified using the uh, multiplexer set me clear in combination with P3.3 and P3.4. So I will illustrate this later with a drawing. So what is the importance of executing the clear instruction? So it chooses the second from the left digit of the 4-digit 7 segment display. So the combination is 1 1 1 0 01 and 00. Okay, this also follows the concept of multiplexers. Okay, so what are the other instructions of the program? Oh, okay, so we are now at step 10. So add two sets of input and activate the third and fourth SSDs. So in order to do that, we can use the logic of the multiplexers and have a new function called 3, and we first set the so this is 1 1, and now we have 1 0, and we must so we have 1 1 1 0 0 1. So we set B 3.3 and then clear B 3.4 and then proceed to our function. So let's just follow the same concept. We add the delay, we clear A, we move A to P2, we move P2 to A, and we move A to P1, and then we call a delay again. So we have 4. So of course we clear the P 3.3. So the combination is 0 0. So we call delay, we clear A, we move P2 to A, and we move A to P1, and then we call a delay. Okay, so I think this will work. So no error. So let's run. Let's see. Then, oh, I'm not inputting anything, so let's just turn on random switches. Right, okay. So let's just make a 0 or a 8, an 8. Okay. We are now at 3. We are now at 3. So we are now, so that is the last delay, and we have another delay before reading the inputs. Okay, so we are now at 4. So as you can see, we move from leftmost digit to the rightmost digit of the 4-digit 7 segment display. Okay, so let's answer. Let's reset. So I believe this, we will just copy paste this one. So question 3, 4, and 5. So what are the added instructions of the program? These are the added instructions of the program. So let me just fix the format. So there. What is the output of the program? So the output of the program is based on the switches that were pressed and and shows and output output it on the P1, which is the 4-digit 7-segment display. The the digit to be used for displaying the inputted values is predicted or is predicted what they call this is determined by the multiplex by the value of the multiplexer P3.3 and P3.4. So I will add an illustration later. So what is the effect? So as you can see earlier when I was testing this, so let's try uh, use the frequency 100. Let's input some numbers. So let's see. Let's put it to 100. So let's wait for a minute, but I believe that the output will be stuck on the first digit, on the leftmost digit of the 4-digit 7-segment display. So as you can see right here, okay, we now have a 1 delay, we have 2 delays, 3 delays, 4 delays, 5 delays, 6 delays, 7 delays, 8 delays, 9 delays. So as you can see, we passed many delays and the output is still here and it is not updating. So let's change the combination. So okay, 1, 2, 3, 4. So as you can see, the output is stuck on this value. So let's answer that. So the frequency 100, this level of frequency will make the program display the value will make the program read the input from the switches once and display it once on the leftmost digit of the 4-digit 7-segment display, regardless of how long or what new combinations are inputted. The output will be the same and is based from the very first uh, input and 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 moving, what do you call this, moving and input, very first input from the switches and the space on the input, and the display will be always at the function 1. So that is for my question 5. So I think we answered everything. So let's see. I have an answer here. So Q5. So see figures. So I think that's it for my uh, performance of the experiment 3. So let me just save this to let's overwrite. So I think that's it for my experiment 3 demonstration. Thank you for watching. My name is Castillo, CPE from CPE108L, section E01. And thank you.